So in this video we will see how can we find the Nash equilibrium using backward induction method. So let's say we have two players. We are assuming the game ourselves and we will arbitrarily give them payoff, and each have strategy to either in or out. So player 1 will move first and it will choose between in and out, and then player 2 will move and he has the option to in and out as well. So this is the game of perfect information. That means each player has perfect information about the strategy being adopted by the other player. So when both players opt for in, they get the payoffs of 5 and 5, and when player 1 in and players 2 choose strategy of out, and he will get the payoffs of 3 and 4. When player chooses to stay out, he gets the payoff of 4, whereas player 2 gets the payoffs of 5. On the other hand, when both the player chooses to stay out, they both get the payoffs of 2 and 2. So we will start from the bottom and we will go upward to solve the backward inductions. So the player 2 is at the second decision node, so first we will compare the payoffs of player 2. So between 5 and 3, the 5 payoffs is greater, so player 2 will choose strategy of in, and in that case he will choose strategy of in as well. So player 2 will choose the strategy of in when player 2 chooses the strategy of out, and player 2 will strategy of in when player 1 also ends. So now we will come to the payoffs of, we will compare the payoffs of player 1. So player 1 will consider only choices the player 2 has adopted, so he will compares between the choices of 5 and 5 and 4 and 5. So between 5 and 4 we will consider now the payoffs of player 1. So between 5 and 4, player 1 will choose the payoffs which gives him greater payoffs, so he will choose the strategy of A. So we get the two lines here. That means the Nash equilibrium for this game is each player will strategy to in, and each will get a payoffs of 5 and 5. So this is how we find the Nash equilibrium using backward induction method.